Today we're going to look at different aquatic properties. An aquatic place could be anything like an ocean, a lake, a pond, or an estuary. The first slide we're looking at is based upon sunlight exposure. If you look here, you notice that there's a lighter color blue that progressively gets darker. That, of course, is because sunlight can only penetrate so far down into the water. There's two vocabulary words here. There's photic zone and there's aphotic zone. Photic zone is where sunlight can get through. So if we take a look here, as you go down to about 300 meters, that's where you start to get light cut off. So anywhere from 0 to 300 would be the photic zone. This is also where photosynthesis can occur. Anything below 300 meters would be the aphotic zone, where no light can get through, therefore no photosynthesis can occur. Now we're going to take a look at temperature and depth. If we look at this graph, as depth increases, or we could say as it gets deeper, the temperature has a major drop-off. So it's warmer at the top of an aquatic zone or an ocean, pond, lake. It's warmer at the top, colder at the bottom. That also has to do with the amount of light that can get through. Next, we're going to look at salinity. Salinity is the amount of salt in an aquatic zone. So if we look here, as depth increases or as it gets deeper and deeper, the amount of salt or salinity increases. So we could also say the deeper the ocean, the saltier it is at the bottom. Okay, of course this is not the case for freshwater because there's not an abundance of salt in freshwater. Now we're going to take a look at nutrients. Nutrients needed for photosynthetic organisms. So again, as you increase in depth or as you get deeper into an aquatic zone, you have less nutrients, all right? You have more nutrients at the top. Again, photosynthetic organisms use this nutrients, so that's why it's towards the top. That's where the photosynthetic organisms are. So just a recap for you. As depth increases in aquatic environments, salinity also increases. Temperature decreases, or it gets colder the deeper that you go. Sunlight also decreases, or you could say it gets darker the deeper that you go. Nutrients also decrease. They're towards the top for those photosynthetic organisms. Plant life and other photosynthetic organisms use up a lot of nitrogen and phosphorus near the top. Now we're going to take a look at two different zones. There's the intertidal zone, as you can see here. It's the part right near the beach, right at the mouth of the beach, where during high tide, it's covered in water. During low tide, that's when you can start to see all of the organisms that live there. So if you take a look at this picture, we have some crabs, sea stars, some other coral, different snails, clams, that sort of thing. During high tide, you can't see them because they're underwater, and during low tide, you can. They are specialized to be able to withstand long periods of time out of the water. This is the intertidal zone. And last, an estuary. An estuary is an area of water where salt and fresh water meet. Here in Florida, that would be where the mangroves are. Estuaries are important for living organisms. A lot of animals will come here to raise their young, to give birth and to raise their young, because it's full of nutrients, full of organisms, and it's quiet, not a very strong current. Estuaries are also important for us because they are good defenders from tsunamis, storms, hurricanes. The water and the makeup of the estuary can stop those big waves from coming towards where homes and people are. So estuaries are very important to us as well. And last but not least, we will watch a quick video on estuaries.